All right, guys, questions on the assignments so far? Because we have 3 assignments so far, 7-1, 7-3-1, 7-3-2. Questions on any of the homework assignments that we want to look at or go over? Let's leave that there for today. Yeah, you're good. Because what we're looking at today is addition and subtraction, adding and subtracting rational expressions. Now, when we add or subtract rational expressions, the denominators have to be the same. And this is true for any type of fraction. Because if we add 3/4 and 7/4, because the denominators are the same, we just add the numerators. 3 plus 7 would be 10. 10/4. If there is any possible way to simplify, we will. So 3/4 plus 7/4 would give us 10/4, which would reduce to 5/2. And the same thing is true with our rational expressions. So we'll get the denominators the same, add the numerators, and then simplify if necessary. So if we look at the first one, 7/4x plus 3/4x, are the denominators the same? Yes. So since the denominators are the same, they're both going to be 4x. And we can add the numerators. 7 plus 3 is indeed 10. And we have 10/4x. Can this reduce? Yeah. So we'd have 5/2x. And again, we still have restrictions just like we did before. It would just be whatever would make the denominator 0. In this case, it would just be that x cannot be 0. Because we're just saying what would make 2x be 0. Well, that's just 0. Questions on A? We good with A? Let's look at B. 2x over x plus 6 minus 5 over x plus 6. Are the denominators the same? Yeah, the denominators are the same. So we can subtract the numerators. Since the denominators here are the exact same, we can go on and subtract the numerators. Normally we would put parentheses around, especially the second one. But since they're both one term, we don't necessarily need it here. Well, are 2x and 5 like terms? No. Is there a greatest common factor between 2x and 5? No. So we can't factor anything out. 2x minus 5 is not the same thing as x plus 6. So that's actually as far as that goes. We ready for the next one? Now the next one we're looking at is this one here. We have 8/12x minus 5/12x. And again, simplifying is one thing that we've been doing for quite a long time, and it's very tempting to want to simplify the 8/12x because they both have a common factor of 2, yes, and 4. 4 is the greatest common factor, yes. But to be able to subtract or add like expressions, especially these rational expressions, the denominators have to be the same, yes? So if I reduced the 8/12x, the denominators would not be the same anymore, and we could not subtract. So we're going to leave them alone for now. But because they are the same, we can subtract the numerators. Well, 8 minus 5 is 3. Now our 3/12x would reduce to 1/4x. If the denominators are the same, we can add or subtract the numerators. Questions on this here? Let's go and look at the next one. 2 over 3x squared plus 1 over 3x squared. Well, the denominators are both 3x squared, yes? So we can add the numerators. 2 plus 1 is 3. 1 over x squared. Because when the denominators are the same, we can add or subtract the numerators. Questions on these two here? Are we ready for the next two? Yes? All right. 3, 4x over x minus 2 minus x over x minus 2. Again, the denominators are the same. So we can subtract the second numerator from the first. And again, if there's more than one term, especially in the second one, we would put parentheses around it because we're not just subtracting the first term in the numerator of the second, we're subtracting both. So it does have a sign change. But here, 4x minus x is 3x over x minus 2. And that's actually as far as we can go. Because as much as we want to simplify the 3x and the x in the denominator, we can't, because the x in the denominator is attached with that minus 2. It is one expression. We can't just cross it out. If it had been x times x parentheses x minus 2, close parentheses, then we can. But this is as far as that one goes. Questions on this one here? So far, all these have done pretty well. It's pretty much we add, subtract, had some small simplifying. It's not been too bad. Let's look at the next one. Again, like all the ones we've done so far, the denominators are the same. So we can add the numerators. So we'd be adding 2x squared and 2, yes? So when we add the numerators or started off, we'd have 2x squared plus 2. 2x squared and 2 are not like terms, so we can't combine them. But there is something we can do with the numerator. Do they have something in common? They both have a greatest common factor of 2. Since they have a greatest common factor of 2, we can factor it out. And if I factor the 2 away from 2x squared, we're left with x squared plus 1. Because we're really dividing both terms by 2. 2x squared divided by 2 is x squared. Or 2 divided by 2 is 1. Anything in common on top and bottom?
X squared plus 1.
So we have x squared plus 1 over x squared plus 1, yes? So those cancel out, yes. Leaving us with 2. Now, funny enough, because again, we haven't talked much about restrictions, and there's not much, especially even on the test. I'm not going to ask you for the restrictions for addition, subtraction, multiplication, division. I'm not going to ask for those. Here, again, the denominator, x squared plus 1. Any value of x that would make this be 0 would be a restriction, yes? So what we could do is set it equal to 0 minus 1 from both sides. X squared is equal to negative 1, yes? So any value of x that we can plug in to that and square it and get a value of negative 1 will not work. Well, this should look familiar from last semester, yes? Because at this point we would do what? Square root both sides, saying x is equal to plus or minus. What did we say the square root of negative 1 was? I. So we're saying that x cannot be positive or negative I. Is that a real number? So is there any value of x that would make this denominator be 0? No. So this here, there are some where there is no restriction, because there is no possible way to make the denominator be 0. So it's not always going to work out that there's a restriction, because there's some that just don't. Questions on this here? All right. We like adding or subtracting rational expressions with unlike or with like denominators. If they are not the same, we have to make them be the same. Now, we've done these before. 2/3 plus 4/5. Because if we're going to add these two together, we need the denominators to be the same. What is the first number we can turn both 3 and 5 into? 15, because if we look at these here, we're trying to see what do I need to turn this 3 into and this 5 into so that they are the exact same. And 15. Now what this is called is least common multiple. Least common multiple, it's the least number, the smallest number that we can turn both 3 and 5 into. Now when we're talking about least common multiple, we're going up. So whatever the least common multiple is, especially with two numbers, is never going to be smaller than either number. The least common multiple for 3 and 5 will never be smaller than 5 because we don't want to go down. We want to go up. Greatest common multiple, we've done those, is never bigger than the smallest number because it's what we can take out of both. Now the general process, and we'll go through this here, is breaking these numbers down into their prime factorizations. Prime factorization is just the multiplication of all the prime numbers that give us that there. Case in point, 8. And we do a factor tree to get there because 8 is 2 times 4. Well, 4 is 2 times 2. So the prime factorization for 8 would be 2 to the third power. That's prime factorizations. We want to see how many of each prime number goes into that to give us the whole one. And from there, we take the most, whichever one out of all the numbers has the most of that term, we take it to apply to the least common multiple. Now, unfortunately, with 3 and 5, both 3 and 5 are prime. So for the 3, we would need the 3. And the 5, I would need the 5. 3 times 5 is 15. So the least common multiple, or well, we'll call it least common denominator technically because it's the bottom of the fraction, would be 15. So for us to be able to add or subtract these, both denominators have to be 15. Now the reason we do this and not pick another number, because there are others, 30 also works, but any number we go past, the least common multiple, least common denominator, is going to add a set of factors on top and bottom that has to be reduced. And we'll see that here in a minute. So we good with this understanding so far? Yes? Now to get there, we need to see what do I need to multiply this 3 by to get it to be 15? Well, I need to multiply it by 5. And what do I need to multiply the 5 by? Well, 3. And we could look at the factorizations of the least common multiple and kind of compare the two. Because 3 times 5 is our least common multiple. Well, the 3 is missing the 5 is missing the 3. We're going to multiply it there. But we're not just going to multiply the bottoms of the fractions by the 3 or 5, respectively. We also have to multiply the top. So we're going to multiply 2/3 by 5 over 5, and the 4/5 by 3 over 3. Well, 5 over 5, 3 over 3 is just a fancy version of 1, so we're not changing anything, we're just changing how it looks. Well, here our 5 times 2 is 10. 10/15 is still 2/3. 4 times 3 is 12. 12/15 is still 4/5. Same fraction. But because the denominators are the same, we can add the numerators. 10 plus 12 is 22. If there's a common factor at this point, we would reduce it out. 22 and 15. Well, 15 is only divisible by 1, 3, 5, and 15. 22 is not divisible by 5 because it doesn't end in a 5 or 0. We can check 3. Well, 2 plus 2 is 4. 4 is not divisible by 3. So that's as simplified as it gets. Questions on this here? Now, as I said, the least common multiple is what we aim for. I'm going to do this again. So I would just watch this time. And that's gone completely. Because I could also make them both be 30. To get 5 to 30, I would multiply it by 6. Because 6 times 5 is indeed 30. 6 times 4 is 24. We could plug 24 over 30 in the calculator and see that it is indeed still 4/5. Nothing's changed there. 3, I would multiply it by 10. 10 times 2 is 20. 10 times 3 is 30. So it's still 2/3. Denominators are both 30, so we can add them. 20 plus 24 is 44. Is there a common factor between these two now? Because 2 for sure, yes? If we divide both of them by 2, 44 becomes 22, 30 becomes 15. Well, if we think, let's get a color, this one here, because originally we multiplied the right side by 3 over 3, the left side by 5 over 5, yes? What factor did I just include in both sides? 2, yes? I included an extra factor of 2. Well, what did we end up dividing the final result by? 2. That's why we want to get the least common multiple, least common denominator. Because every value, extra value we add to the least common multiple comes back out in the end. Does that make sense? And I mean, for numbers, it's fine. With numbers, there's no issue with it whatsoever. Because we can do this, and then, well, 44 over 30, that's easy to reduce. Calculators can do that for us. Those are nice. The issue comes in with these rational exponents. Because if our final answer is supposed to be this here, and we add an extra x plus 1, the numerator becomes this here. The denominator becomes this here. We added on top and bottom. The degree of the top just went from 1 to 2. If we add 2, another one is going from 2 to 3. We now have x cubed. And anytime we go above it, it's going to make it more complicated than it needs to be, and all those factors will come back out. Does that make sense? So it's going to be crucial we find this least common multiple, this least common denominator. So before we even jump into adding or subtracting rational expressions with unlike denominators, I want to go over least common multiple a little bit. Okay? Now the graphing calculator can do these just fine, but it's going to be good to get a grasp of this first. And what we're going to do is we're going to take 8, 14, and 16 into their prime factorization. We're going to do factor trees. I know it's probably been a minute since you've done a factor tree. Always start with the smallest prime number, and it's not 1. Smallest prime number is 2. So we can do 8. And 2 does go into 8. It's 2 times 4. Then we'll look at 4, which is 2 times 2. So our 8 is 2 to the 3rd power. Because we have 1, 2, 3 2s. Because we were only looking at the prime numbers and counting them up or grouping them together. Because 4 is not considered prime, it's our 2 squared. So we group those together. Does that make sense? 14. 2 and 7. So its prime factorization is 2 times 7. 16. 2 and 8. 8 is 2 and 4. And 4 is. Well, 16 would be 2 to the 4th. questions on this here so far? So least common multiple. For the least common multiple, we take whichever one has the most of each term. And the first one we can look at 2. 14 has 1. 8 has 3. 16 has 4. So which one would we take? 16, the 2 to the 4th. So we could write it as 16. I'm going to write it as 2 to the 4th for now so we can see that. Because again, we're taking which one has the most. With the greatest common factor, we would just take whichever one had the least. So we would take the 2 from 14 for greatest common factor. Least common multiple, we take whichever one has the most. And if there's a tie, take either one. Doesn't really matter. Now the only other number that we have is 7. So the least common multiple for this here is 2 to the 4th times 7. Now at this point here, you can plug that in the calculator, let it calculate that for you. $112. So the least common multiple for this here is 112. That's it. That is it. I feel least common multiple for our rational expressions, I think is a little bit easier than this because it's more just looking at it. We don't have to do as much with breaking everything down. Now, before we do that, I do want to do at least one more with numbers. I'm hoping that doing this will help a little bit with seeing how this works. We have 9, 12, 15. Well, 9. 2 doesn't go to 9, but 3 does. 3 times 3. So we have 3 squared. 12. 2 times 6. 6 is 2 times 3. Now we have 2 2s, so that would be 2 squared. And we have 1 3, so it'd be 2 squared times 3. 15. 3 and 5. Least common multiple, we're grabbing the most from each one of these here. Well, there's only one of them with 2's, yes? So we will need those 2's, which actually works out to be 2 squared. Then we can move on to 3. We do have one with 1 3, one with 1 3, and one with 2. So we're going to take the one with 2. And last we have 5. So our least common multiple, 2 squared times 3 squared times 5. Questions on this so far? Questions on any of this so far? We feel good with this here. Yes? Now, I should have mentioned this on the last one. We can go back to it. But that's the least common multiple. Least common denominator. So if we're going to add or subtract the fractions that had these, we need all 3 denominators to be 180, yes? So for the 9, well, we do have this 3 squared term, yes? What is it missing? Well, it's missing the 5 and the 2 squared. So to get those denominators to be the same, I'd have to multiply that fraction by our 5 and 2 squared, yes? Let's look at the middle one. The middle one, we'll get another color, has the 2 squared already, yes? We can see for certain it is missing 5, because it's missing the 5 completely. But we're also missing 1 3, because we only had 1, we need 2, yes? And the last one, let's go with purple. It does have the 5. It does have a 3, but it's missing another 3, and it's missing both 2. So for the 15, we would multiply it by our 2 squared times 3. We kind of see that there. That's why this is helpful, because the least common multiple gives us what the denominators should be and what we need to use to get it there. Does that make sense? Kind of a little bit. And we've done these before, so it's a good place to start. Now we want to find the least common multiple for 4x squared minus 16 and 6x squared minus 24x plus 24. With multiplication and division, I mean, with division, we did our keep, change, flip. But after that, for both of those, the first thing we did before we started doing anything else, we factored it, yes? Least or greatest common factor. Any of those errors, we factored them. That's the same thing here. We need to factor these first. So if we look at 4x squared minus 16, there's a greatest common factor of 4. And if we factor it out, we're left with x squared minus 4. We can factor it again, x squared minus 4, yes? That's one of our ones that we like because it's a difference of perfect squares. X squared minus 4 would be x plus 2 and x minus 2. Now it's completely factored. There's no other greatest common factor inside each set of parentheses. The degree is 1. That's as far as that one goes. So we can move on to the next one. 6x squared minus 24x plus 24. Greatest common factor of 6. And if we factored it out, we get 6 times x squared minus 4x plus 4. X squared minus 4x plus 4 is factorable. Third term is positive, so the signs are the same and match the sign of the middle term. Minus and minus. Only factors of x squared are x and x. Since there's not a number in front of it, it's just going to be our x and x. Factors of 4. 1 and 4, 2 and 2. We can do 2 and 2 first, and we do check this. X times negative 2, negative 2x. Our negative 2 times x, negative 2x, which does give us our middle term of negative 4x. So these are the factors. Least common multiple of 4 and 6. Let's start there. Well, we do kind of have to break these down, yes? Because if we did the factor trees for 4, that would be 2 times 2 or 2 squared. I can do 6 over here. Well, 6 is 2 times 3, and that is it actually, yes? Kind of like what we did on the last one. So our least common multiple here, well, 4 has 2 2s, 6 has 1, so we'll take the 2 squared. Well, we also need the 3 from 6, yes? So we'll simplify that here in a second. So numbers, we've done a few of those. That kind of makes sense, yes? Well, 2 squared is 4. 4 times 3 is 12. Because the first number we can turn both 4 and 6 to is 12. Okay? All right. I find polynomials a little bit easier than just numbers. Because once we get them factored, even here, we got it factored down, we still had to break 6 and 4 down farther. Yes? But if I look at the rest, well, let's start with x plus 2, because we'll start with one of them, yes? The one on the left has how many x plus 2's? 1. How many does the one on the right have? 0. So I need at least one x plus 2. Since one of them has it, least common multiple has to have it once. Let's move on to the next one, x minus 2. So we did this one, x minus 2. How many do we have on the left? How many do we have on the right? 2, so how many times do we need it? Twice, because again, we take it from whichever one has the most. Since one of them had 1, the other had 2, we take 2. So our least common multiple for these two here is 12 times x plus 2 times x minus 2 times x minus 2. And that's it. That's also why I like just polynomial factors a little bit better, because we're just looking at them. And some of the times what we could do is just take all our sets of parentheses from one and see what it's missing from the other. Now to make these be the same, well, for our one on the left, we would need to multiply it by 3 to get us to 12. And it's missing an x minus 2. The one on the right, is missing a 2 to get it to 12, and an x plus 2. So we'd have to multiply the one on the right by 2 times x plus 2. We'd have to multiply the one on the left by 3 times x minus 2. It's going to be the same. Questions on this here? Would we say this is a little bit easier than we thought this was? Yes. We can do the one on the left or one on the right first. It's up to y'all, because we'll have to do both. Which one do we want to do first? Left. 6x squared minus 54. Is there a greatest common factor? 6. So we factor the 6 out of 6x squared and 54. We're left with x squared minus 9. X squared minus 9 is nice, because again, it is a difference of perfect squares. And when factor 2, x plus 3 and x minus 3. So in our least common multiple, I know I will need at least an x plus 3 and x minus 3. I need one of both, because it's listed at least once in both, so the least common multiple have it at least once. Any questions on our first set of factors? We ready for the next one? Greatest common factor is, because 9 does go into 9 and 81, and it does go into negative 54. Because if we factor the 9 out, we have x squared minus 6x plus 9. We have 2 sets of parentheses with 3 spaces. Third term's positive, so the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared and x. Factors of 9, 1 and 9, or 3 and 3. Least common multiple. So we're going to have to find the least common multiple of 6 and 9. I think at this point we do feel pretty comfortable with that. Yes? So we'll do it in 2 ways. One, we'll do it here. So I'm going to write off to the side 6, 2 and 3. 9 is 3 and 3. So that is same as 3 squared or 2 times 3. 3 squared times 2. So 18 is the first number we can turn both 9 and 6 into, yes? Yep. Hopefully this is loaded. Saying quit. Math on the graphing calculator, not the 30XS, but the graphing. If we hit our math button and go over 1, if we look at the very bottom, we do have LCM, least common multiple. So we can scroll down to it or hit 8, 6, comma, 9 is 18. So it can do that for us. Now, if you want to do 3 numbers, we have to, what they call, embed it a little bit, because we can say least common multiple, math, least common multiple of 6, comma 9, comma 4. All we're doing is taking the least common multiple between 6 and 9, getting that result, then taking the least common multiple with it, which is 18 and 4, and getting that result. Does that make sense? So you can do it twice, or you can just do them individually. 18. Okay. I'm going to show you the way we just did the last one, then I'll show you another way to do this. We can look at x plus 3 first. The one on the left has 1. The one on the right has none. So the number that we need for our least common multiple is 1. We just need 1x plus 3. X minus 3, we have 1 on the left and 2 on the right, so we need 2 of them. So our least common multiple, what the denominators would have to be if these were our expressions, would be 18 times x plus 3 times x minus 3 times x minus 3. And to get them to be the same, the one on the left, we would have to multiply this by 3 to get our 18. And we need a second x minus 3 for them to be the same. The one on the right, we'd have to multiply the 9 by our 2, because again, it's this here, and an x plus 3 to get them to be the same. Because that's what this least common multiple is telling us. It's telling us what the smallest thing that we can make both denominators be without causing issues. Questions on this here? Because this here is the key to solving and adding and subtracting and our complex. Last one we're going to do. This one's kind of nice. 5x squared. 5x cubed, sorry. One term. That's factored. It's not going to get any simpler than that. 10x squared minus 15x. Greatest common factor of 5x. So we can factor the 5x out of 10x squared and get 2x minus 3. Luckily for us, the number in front, 5 and 5, those are already the same, yes? So part of our least common multiple would be 5. Now we're going to look at x cubed and x as a separate part. The one on the left has 3. X is yes. The one on the right has. So how many x's would we take? 3. Because we're taking whichever one has the most. Well, the only other thing left is, so it would be included. And if we're trying to get these to be the same, well, our 5x cubed is just missing the 2x minus 3. Our 5x times 2x minus 3 is missing the x squared, because we need it to become x to the third. So we multiply by x squared. Because again, the least common multiple is the smallest thing that will make both of them be the same. That's the goal. And we can use that to determine what we need to multiply each one by to get them to be the same. And we'll apply it to top and bottom, just like we did on the first one with the fractions, our 3 over 3, our 5 over 5, to get them to be the same. Because that's going to lead into this here.